Assalamualaikum and good day all. Today I would like to introduce the air conditioning system and equipment. So firstly I would like to introduce the type of aircon with their character of aircon. So basically the equipment of aircon systems will be content of mixed air plenum, outdoor air control, air filter, supply fan, exhaust or relief fans, and an air outlet, outdoor ducts, terminal device until to air handling unit. Okay, this will be the basic of equipment should be there in the inside of the aircon system. So before I introduce all the equipment, uh, should we introduce first the type of account and then which account should be contain of several of equipment only or all equipment need to satisfy in one system of account. Okay, actually, based on the classification of aircon, we have the cooling heating fluid used based on the classification of cooling. So we will divide type of the aircon system, and then based on the unitary central system, we can divide several system of unit aircon system, and also with a single or multiple zone type of aircon system. So from this classification, we can get several type of aircon, right? Okay. We go first to know the character or the type of a single zone. And then we go to next type of the ecosystem. Okay, we go first here, single zone of icon. What is the single zone of icon? Single zone icon system has one thermostat that control one heating or cooling unit to maintain proper temperature in a single room or a zone. For example, window air conditioner, yeah, window air conditioner. And then the second one, air handling unit, cool or heat air that is then distributed to the one room only, or single zone. So for single zone, we only set one condition. So if we have more than one zone, should we separately control the temperature or the humidifying, humidifying control, anything. So this one consider is single zone. And for multiple zone, we control, we have the characteristic in the multiple zone. First, for the first characteristic is reheat system. So the multiple zone, they should be create or build the reheat system. The reheat system can be supply the constant air volume, or we call it the short form CAV. Some can control by variable air volume, and then good control of each zone, but waste of energy, and room thermostat located in each zone. So actually, if we implement of multiple zone by this character system, we build a reheat system. So the character only support constant volume, right? And then good control, but will uh, get a result in the inefficient energy. We will we will utilize much of energy. And then multiple zone with the multi-zone system. So actually we can control also by multi-zone system by this type. Right? We can separate duct run from each set of damper to each zone. So by using damper, we can separate the duct system flow in the air supplier. Yeah? And then cold and hot air are mixed in varying proportions by damper according to zone requirement. So we can control by implement of damper. So damper will use if we try to mixing the air condition, cold and hot of air condition. And humidity may not be satisfactory and limited to 12, 14 zone. So maybe we can create a limited only 14 maximum zone. In expensive system, for small and medium sized application where humidity conditions are not critical and energy is wasteful. So maybe it's not efficient or using multiple zone. Okay, now the other characteristic multiple zone of air is dual duct system. We can separate hot and cold main duct. So within the, maybe we can separate duct system that supply hot and then duct system for the hot system. So hot and cold we will meet in maybe in certain position, and then we'll mix and then we supply to the certain room if we need, and then we can make a ratio, the mixing between the hot and the cold condition. So by using the damper, we can separate that condition. So when the outside temperature falls, reheat coil operates so that humidity can be reduced, which need extra energy. So maybe we will implement the sensor to detect the outside temperature. If the temperature is false, so to maintain temperature indoor by activate the reheat coil, by operate the reheat coil, and then we can maintain of the humidity and temperature. And then we go to the next bullet, designed as high velocity air system in order to reduce duct size. Therefore, sound reduction system is built into them. So we can design duct system by reduce the size. The size is important because when we first invest costs, we will reduce the duct size, and not only for reducing of cost, but also we can reduce the sound reducing section from vibration of a duct. Yeah, and then great flexibility in handling many zone with the varying load. So we can control the flexibility many zone. So some zone need the certain condition, we can control, we can make condition, and then we can satisfy and supply to that zone. And another zone with their condition, we can so control with their condition also. Then install cost high, fan horsepower are high because of large volume of air move at high pressure. So if we install one set of the multiple zone, we should be also invest much of the equipment. Especially we need the fan to supply the air to every zone. correct? And then energy should be wasteful, so it's not efficient. Okay, we can check the diagram of dual duct system here. Okay, because of dual duct system is separate within the cold and hot, you can see here. Yeah. So in the upper side is a hot duct system, and then the lower side is for cold duct. So what happened from this condition, we will mix within the duct. We can see here mixing box, S1, S2, S3. Yeah, so we can control. We can control based on the zone. So how much the ratio within the hot and the cold. Okay, then the multiple zone, we can see the characteristic. Also, we can control by variable volume system. We can control. So varies in air quantity rather than T to maintain T, piping and control factory install, configure tester, LED display, and manual control. So by applying in all these equipment in the multiple zone system, we can maximize the operation. Yeah. So in the system of the multiple air condition, we also not control for air system. Also, we control the water system inside. Yeah, distribute hot chill water from central plant to each space, and no air is distributed. And hydraulic terminal units such as a fan, coil units, heat or cool the room air. So based on this condition, we have several advantages and also disadvantages. Okay, we go first in the advantages. Less expensive and take less space for commercial use. Water has high specific heat and density than air. Less water needed for same amount of heat transfer, resulted in smaller cross-sectional area of piping and duct work. Useful for limited place. It says shaft and ceiling. Yeah, this is very useful for limited place. But also have disadvantage. The first one, multiplicity of fan coil unit means great deal of maintenance work and cost. Yeah, as we know, every diagram as we see before, so many equipment there to construct, because every equipment have function, so should we have high maintenance. Control of ventilation air quantity is not precise. Okay, and control of humidity is limited. So maybe humidity have limited number. We cannot go offer from that number. In the air water system, we can utilize the best feature of all air and all water system. Most energy is carried in water. Air is carried in high velocities, and quantities are only enough for ventilation. Therefore, total shaft and ceiling space required is small. So that's why we have advantage in this type of aircon system. And then two type fan coil unit and induction unit. So we have two type. First, we used fan for the hot and also the induction. And another one condition, we use fan for the cool condition and also induction in the cool condition. So we separate part. So that's why we should be invest in the high cost in this type. Then induction unit very popular in high rise building. So maybe this is one implement in the high rise building only. No, not only, but this one is very popular. Initial cost relatively high. And then after we introduce about the multiple, single and multiple of ecosystem. Now we go to other type of econ. We call unitary system. So what is the unitary system? Unitary is one where the refrigeration and air conditioning component are factory selected and assembled in package. So B in package. So when we utilize or we implement, apply unitary system, so you bring it together one package. So different with the system in the multiple, we should be construct duct system, construct the equipment, distribute every zone, condition, and then we should be control the certain zone, certain conditions. Okay, and then usually located in or close to the space to be conditioned. So actually, unitary system is to be implement close to the space condition. So not too high, very close from the uh, maybe we to the person is not too high. Generally, all air system using generally air system without the water supply system. So different with the multiple air condition. Limited to more simple types such as single zone unit with or without reheat or multi-zone unit. So from the for construction, maybe is simple compared to the multi-zone unit. Up to 3-ton refrigeration capacity. So maybe smallest compared to multi-zone unit. Unitary system and equipment can be divided into 3 groups: room units, unitary conditioner, and rooftop unit. Okay, you can see here room unit available in 2 types: window unit and through the wall. This one is a old school type. Maybe we don't use anymore in this type. Room unit have advantages: low cost, simplicity of installation and operation, but have much of a disadvantages compared to advantages. No flexibility in handling high latent heat against or change sensible heat ratio, resulting in bad humidity control, and then air cleaning quality is minimal, and then higher sound level, maintenance burdensome and expensive, and energy wasteful. Okay, but wasteful in the multiple use because can I adjust the capacity. Okay. Now we go to unitary air conditioning by central system. This one unitary. Designed to be installed in or near to conditioned space. Okay, the space is so maybe attached to the ceiling, to ceiling. And then component contained in the unit available in vertical or horizontal. So you can see horizontal and also the vertical. Limited amount of ductwork can be connected if air distribution with outlet is desired. 2 types of arrangement. The first one is all component package except condenser, which is located outdoor, and the second one split unit where condenser and compressor are unit as one package and located outdoor, fan and cooling coil in another package located indoor. So some is separated. In this case, it's separated. In this case, separated within the outdoor condition and indoor condition and package. Less noise, more accessibility, suitable for maintenance, and no problem of finding suitable space in building. And then up to 50-ton refrigeration, so we can get the high power of condition in unitary air conditioning. Yeah, and then we go to another type, rooftop unit. You can see rooftop unit. Some building we sometimes using this type of air conditioning, designed to be located outdoor and installed on roof, used with ductwork and air outlet, must have weatherproofing features for equipment located outdoor. Electrical part must be moisture proof. Casing exposed part must be corrosion protected. Do not use valuable building space. Low cost, available in multi-zone arrangement. Humidity control is limited. Also limited, yeah. Okay, you can see how the central system diagram work in the, this one is a home in the house. So we have three maybe, the level of house, for example. So all components are separated. You can see maybe component every room. Every room is different, but for one control condition. For temperature, all condition for temperature, humidity, anything. It's selected by designer and installed and connected by contractor. Usually located remote from the conditioning space. Each component may be not remote from each other. Totally, the contractor will build in the house by the ducting system. Okay, we go to the air handling unit. Or sometimes we heard by short form AHU. What is the EHU? Device used to condition circulate air as part of heating, ventilating, and air conditioning system. Usually large metal box containing a blower, heating or cooling element, filter, rack or chamber, sound attenuators, and damper. Actually, in the one package, they have a several equipment inside, and then covered by the large metal for covering. So the cover or equipment like filter, chambers, sound attenuator, damper, some fan, some use a fan. And the air handlers usually connect to a ductwork ventilation system that distributed the conditioned air through the building and returns into the AHU. So maybe the circulation will develop inside the AHU from the side outlet to inlet of the AHU condition. Two arrangements, single zone and multi-zone unit. So we can create for both condition, single or multi-zone. And then medium capacity system, AHUS are factory made in a section, fan section, coil section, edge number size. So sometimes they already developed by the company and factory with the certain condition and size. So based on the we design based on our design, and then we can propose to the factory, or based on the market size, maybe we can buy. For large systems, separate coil, filter, and fan are selected, and casing are fabricated by contractor. So sometimes contractor using for size, for big size condition, and then they separate coil, filter, and fan are selected based on the contractor needed. So the factory will it inside. Okay, air handling unit, casing made from the galvanized sheet metal and insulated energy losses, and then drain pans under the cooling coil to collect moisture, and piping connection must be provided to prevent water from circulating into the air condition ductwork. Illuminator are provided downstream from the coil, consists of vertical Z-shaped baffle that tap droplet which they fall into the pan. Access door should be provided for maintenance. So should we have the door to maybe to give the access to the equipment inside to maintenance, like fan, like filter, coil, anything inside of the AHU. So we have maintenance time in the certain during operation. So air handling unit, when the fan located downstream of the cooling coil, the unit is called draw-through type. Okay? When fan in the upstream of the coil, the unit is called blow-through type. Okay, different of the flow, different name of condition. So we call located downstream, it's main coil unit called draw-through type. If we the flow condition to upstream, we call blow-through type. So different position of fan, different condition, type of air handling unit. So draw-through is preferable because the air will flow more uniformly across the coil section when drawn through by the fan. So to aid in distributing air more evenly in blow top unit, perforated plate is sometimes located between the fan air. Okay, we can see the diagram here. This is a structure of the type of AHU fan location. So you can see from the left side, this left side is mentioned where the outside air inside go to inside to the system. So after that, we'll go first to damper. Damper will control the air volume condition. Then to the filter go to coil in the heating condition, and then go to cooling coil, and then reheating again, and then to go to centrifugal fan, and then supply to next maybe to the duct or the other duct or to inside room. So this one is located, fan location is end of the supply air. And then another type is blow from the initial inside of AHU system. Just now, the fan condition location is the end of the AHU system. Okay, this one is component in the AHU system. You can see how many equipment inside here, the AHU system. From the outdoors to be complete to inside, then complete to in the system to back to exhaust. Yeah? From the outdoor come to inside as inlet, and then operation emission here inside, and then uh, back to the outside. Okay, amount of the this one is exhaust, exhaust air, and then this one the outdoor air must be equivalent. So between the indoor, exhaust to outdoor is should be equivalent. This one, okay. So the number of flow should be equivalent. If you're not equivalent, something stuck here. Yeah. Some system stuck, not stuck. Sorry, maybe not balance is leaking somewhere within the system. Some system use 100% of the outdoor air. For example, laboratories, operation room, where the contaminated exhaust air cannot be recirculated. More outdoor air, higher refrigeration load. Yeah. Sometimes very hot, and then very dusty. So we have much work inside the AHU itself. So coil characteristic. So actually, characteristic have several type and function also. So coil are in direct contact, heat exchanger that transfer heat between air and another medium, such as refrigerant, water, steam, and so on, for the purpose of heating, cooling, and dehumidifying. Coil consists of tubes and external fins arranged in a row along the airflow to be provide a greater surface contact. So coil are arranged in the circuit to create a short path length, and the coil water and refrigerant flow inside the tubes and airflow over the outside surface of the tubes and fin. So actually, the coil, as we know, have the fin by close or cover the tube. So inside tube itself will be flow the refrigerant. So how to the transfer the temperature within the before flow and after the flow through the coil. So by doing the air within the fin. Okay, type of coil. Based on the type of coil, we have several types here. Water cooling coil, indirect expansion. We have steam heating coil, water heating coil. So based on the function and structure itself of the coil. So will be divided in several types. Chill water, cool or cool and dehumidify the moist air that flow over the external surface of the tube and fins. To maintain a higher rate of heat transfer, the air and water normally follow a counter flow arrangement. Okay, actually this one is several types of the coil based on the function. Okay, now we go the first type of the direct expansion coil. The first type of coil we call direct expansion. Sometimes we give it in short term in the DX coil name only, DX. So in direct expansion coil, the refrigeration is evaporated and expanded directly inside the tubes to cool and dehumidify the air flowing over it. And the condensation occur in the outside, the outer surface of the DX coil. So this one is for this coil we will implement to dehumidify, to air flowing. So maybe we will use for indoor air condition. This is why it's called DX coil or wet coil, DX coil, the evaporator in refrigeration system. This one is common use for indoor circulation system. And then fins are extended to surface, are often to call the coil secondary. So we fin. So we have fin covering the tube to distribute the temperature by the air as a medium. And then the material fins is made from the aluminum, because as we know, aluminum have the good in the heat transfer. Coil accessories also have vents to device discharge air from the coil, and drain insulating valve should be have inside there, should be to circulate the drain of the fluid. Then we go to other accessory of coil. We call even distributing baffle here. Baffle is to locate the tube inside the coil system. It's one type of the horizontal type. Coil selection, based on the calculation performance, we will select based on the amount of sensibility of latent heat, condition of air entering and leaving, coil construction number and size of fin, water, velocity, and then the yes, to be velocity in high water velocity increase, heat transfer in high pressure drop required, and then the last is phase. Number 5 is air phase velocity. The phase velocity is the airflow rate in the cubic, what we call cubic feet, cubic feet, yeah, I think. The unit of British for the flow rate, divided by the projected area of the coil. And then we should be consider also how to coil clean lines. Should be maintain the clean lines, and then air cleaning. If we need the air as the cooling condition, should be can go through in the coil system. This one we call the filtration. So in the AHU system also have the filtration system. So in filtration system should be have this characteristic to satisfy the filtration function. The first one, interception. Dust particle may follow the air stream. Streaming, if the filter space are smaller than the size of the dust particle, the particle aerated. The electrostatic effect, particle and filter medium are charged to collect the dust. So sometimes dust we can collect by electrostatic attraction. And then diffusion, we find dust particle, Brownian movement, cause the particle to settle for smaller particle. And then inertial compaction, suddenly change in the direction, cause collision between the dust. So sometimes within the dust, they will attract each other and then make a glum. So like the, grape, grape structure. Okay, based on the figure, this one how to describe, illustrate this character in the filter system. Okay, type of filters would be permanent, stationary and renewable, electronic air cleaner. Okay, for types of filter, we will go in deep. We will go in discuss detail about the filter for next week's. Yeah. Special for filter, we will discuss in the one topic, one single topic. Okay. I think that's all for this week. Yeah. So for your task, should be submit summary from this topic for your attendant. Okay, that's all. Uh, that's all for lecture class today, and see you next week. Assalamualaikum and good day.